Alrighty, here's a video on dividing fractions. We've only got two examples here. We're going to start with 2/3 divided by 8/9. And one of the key ingredients here is to realize that division is the same as multiplication by the what? Multiplication by the reciprocal. Right, we flip the fraction. Which one? Multiplication by the reciprocal means we would switch the second one because we're going to change that to multiply by the reciprocal here. Okay, so we're going to end up with 2/3 times 9/8, the reciprocal being the flip of 8/9 in this case. So now that we're at multiplication, at this point we would be allowed to do cross-reducing if there's any to be done. So 2 and 8, is there a common number that goes into both of those? Yeah, 2. 2 goes into 2 once, 2 goes into 8 4 times. And then how about 3 and 9? Right, 3 goes into 3 once, and 3 goes into 9 3 times. Now at this point, what we can do is multiply straight across, right? Straight across here, straight across there. We're just going to go straight across. And we're going to end up with 1 times 3, 3. Oops, let's change that to true red. 1 times 3, 3, divided by 1 times 4, 4. And there we go. 3/4 is our answer there. So division is always going to be multiplied by the reciprocal. And later on, we're going to remember some things like every fraction is division. So you can turn every fraction into multiplying by the reciprocal of a denominator. We'll talk about that later. So let's go on to this next example. In this next example, what we've got going on here is we've got mixed numbers again. And we found in multiplication that you can't multiply with mixed numbers. So how would we even reciprocate this? Like 1 and 7/8, how do you reciprocate we can't do that yet. So just like in multiplication, we're going to change this to an improper fraction. Then we can multiply by the reciprocal and continue from there. So, remember how to do this? What do we do? Right, the whole number times the denominator plus the numerator. So 2.5 becomes 2 times 2 is 4 plus 1 is 5. 5 halves. Now, we haven't flipped it over yet, so I'm leaving it as division right now. 1 times 8 is 8. Plus 7 is 15, divided by the denominator remains the same, 8. So now that we have that, now we can reciprocate the second term. So what we do is we take 5 halves, the first one stays the same, times, and now it becomes 8/15. Now, if we can cross-reduce, because it's multiplication, we can go ahead and do some cross-reducing. So let's see, 5 and 15, yeah, 5, I made these kind of easy, huh? So we can really see the pattern. So 5 goes into 5 once and into 15 3 times, and then 2 and the 8, yep, 2 goes into 2 once, 2 goes into 8 4 times, and we end up with, when we multiply straight across, right, we end up with 1 times 4 is 4, and 1 times 3 is 3. Now, our answer is improper. It's top heavy. The top number is larger than the bottom one. The numerator is larger than the denominator. So we have to convert it back to a mixed number. So we reverse this process here. Basically, all we've got to do is division and find the remainder, like we did in the last video. So how many times does 3 go into 4? Yeah, you can do that in your head. 3 will go into 4 at least one full time. And if you take 3 out of 4, what's the remainder? 1, and the denominator remains the same, 3. So 4/3 is 1 and 1/3. So notice if you go back, 1 times 3 is 3 plus 1 is 4. So we got right back to 4/3. So why are we doing this, folks? Well, the reason we're doing this is because we're reviewing the fraction skills in all of my classes, because so many of these skills in each of these classes are going to be used for the patterns of the fraction operations, add, subtract, multiply, and divide. We've done 2 of them so far. But those patterns will help us remember how to do other math things And it'll help us build upon that as well. So this is really a very foundational thing. We're going to keep seeing fractions in Algebra 2, geometry, of course, Algebra 3, statistics, calculus, trigonometry. Life is not whole numbers, so you're going to see lots of fractions. Okay? So hope that helps. Hope it gives you a decent reason why we're going to be using this. And, like I said, life's not all fractions. So when you change fractions to a decimal, like our 1/3 there, 0.3333, unless you keep the 3 going forever, as soon as you round it, it's no longer the same. And so it doesn't work as well. We'll talk about accuracy at another time. Okay? But in math, we typically always stick with the exact values of fractions. Don't convert to decimals and then try to convert back because you won't get the same answers. Okay? Hope this helps, folks, and I will see you later. Enjoy. And we go to stop.